Hey everybody, it's Keith with Bob CNC. Welcome to Shop Talk, and I'm here, of course, with my best friend Robert.
And I'm here with my best friend Keith.
And we're going to talk to you about Quadrature encoders.
Wow, that sounded really cool.
Well, you told me I had to do it fast. That was the fastest I could say it.
Okay. So we have CNC machines that have two different types, really, styles of driving the axis to their location. Stepper motors, really popular, and servo motors, also popular, and it gives you an advantage. One is an open loop, which would be stepper motors, and one would be a closed loop.
Now, the difference between an open loop and closed loop, think about having, raising your kids. You send them to clean their room, but you don't go check. That's an open loop. The job might get done, it might not get done.
Right.
You go check, you find out they didn't do the job, and then you make sure that the loop is closed and they do the job.
There you go, closed loop.
Yeah.
So somehow, some way, a stepper motor, they can, but typically they do not. They're open loop. You tell it where to go, and you're just assuming it gets there. If you stay within the parameters of the stepper motors, it does. With a servo motor, you don't worry about it because you have an encoder, a Quadrature encoder on the back. So what is that?
Yes.
It actually is, you got a little disc that has some markings on it, and then you have a sensor that's reading those markings.
They don't have markings.
They do, trust me.
They're spots.
They're really, well, this one actually has markings.
Oh,
the one we're going to look at
I feel bad.
actually has slots. So we have a 500 CPR, or counts per revolution. So what does that mean? There's 500 slots in this disc.
Okay.
Okay? So you have two sensors, one on channel A, one on channel B. They're 90 degrees out of phase, which causes Keith some problems.
Yeah.
It's not temperature, and it's not like in an angle.
Right.
But it's actually, I believe, and I'm guessing, but I think it's because they used to have, there's sine waves and cosine waves.
Yes.
And they're done in time, and you can go look at a cosine wave the way it's created with the circle. So therefore, at 90 degrees, it's a good place to put the next
There's somebody
phase.
that understands this stuff.
And there's a reason for that,
Go
but
ahead.
I think the next slide will help us out with that, okay?
Yep.
So I'm going to try to walk us through this. So this is time.
Yes.
This is nothing more than the light comes on, the light goes off, the light comes on, the light goes off, right? It's just a 0 volts, 5 volts, right? And this is in time. So we're just going to say that this is a second. Stays on for a second, goes off for a second, comes on for a second.
Gotcha.
Okay, so this one actually stays off until this one's been on for about a half a second. So it's right in the middle, 90 degrees out of phase. And why is that important? So again, this one's on, off, channel A, channel B, right?
Right.
Well, this is really cool. Somebody really smart said, if I had two channels that were going on and off, I could keep track when this one changes, when this one changes, when this one changes, and this one changes, and they're all independent, which means I can, with two channels, have 4 times the resolution. So we had 500 holes times 4 signals.
Yep.
I can count 2,000 times. So I know the exact position 2,000 times as I go around the circle.
Okay.
Which is really great for CNCs.
And that's what gives us really good resolution?
Yeah, it is the resolution of the servo drive. So where you have 200 steps per revolution and you can microstep and you can lose torque with the stepper motor. Here, when you're not where you're supposed to be, it just keeps on adding voltage, which turns into current, and it drives that motor where it's supposed to be.
But if it can't get to the place?
Yeah, you know what happens. So you guys have all seen, you've done a project where something's happened and you've missed some steps, or they call it skip some steps.
Yeah.
Something's happened where it's not in the right place. Well, what happens is you'll end up with a double vision or a double pattern or just something right across your work. The one advantage of a servo drive system...
Well, before you get there, the reason that happened is because in your G code, you've skipped steps.
Yeah, it's told you to go 100 steps that way.
Right.
And it's just assuming you did. But something happened, you hit a knot, you hit a tool, you went to, something happened to where you didn't get there and the stepper motor grinded and skipped steps.
Right.
It does not know it, so it just keeps on sending them. And therefore, you're shifted into a different position.
Right.
Or you're going too deep. Something's happened that's bad.
Right.
So with the servo system, it has a calculation in there. And I'm not going to go through this calculation, but...
Good.
But it really is, this is actually on an Arduino microprocessor, and you can get this file, by the way, on our free stuff. I wrote a encoder for my Bridgeport so I can have a digital readout. And this is a part of that. But that whole code is out. But what happens is it's checking those pulses and then it's counting so it knows where it's at.
Right.
Now, my DRO doesn't do this, but what you could do is have a loop in there that says, hey, if I've told you to be at this position and you are not within a certain error of that position, I want you to send 5 volts back to that microcontroller and I want you to tell it. And then that microcontroller can say, hey, I got a servo's not in position, I'm canceling everything. And that's exactly what happens on our KL7 series, right? So if you're running the KL7 series, because it has servo motors on all axes, it is not going to get out of position without faulting out, stopping, and then it's going to give you a soft reset and say, hey, something's wrong, I didn't want to screw up your piece, so I stopped right here.
All right.
And if you want to actually, maybe you wouldn't want to do this, but we did when we were testing. We actually stopped it on purpose, got in front of it, just to see that happen. And it will error out and say, hey, you're not in position, you got to start all over. So anyway, that's really Encoder, the Quadrature encoder. It's not really magic, it's just a cool way of counting pulses, and with some computer algorithms, you can know where you're at.
Well, guys, if you got any questions about the way your servo motor's operated, or servos, or if you're interested in the KL7 series, you can get a hold of us at the help desk at bobcnc.com or at shop talk at bobcnc.com. You didn't trust me. You didn't think I'd get there.
You know.
Till next time, guys.
Bye.